Hey there, my fellow intellectuals. How are you doing tonight? As you can see, I'm back on another night walk vlog with you guys, getting my daily or nightly exercise. Out here, of course, representing astronomy. Got my space mask and my star shirt of the brightest stars in the night sky. You always got to represent astronomy when you got a astronomy/physics YouTube channel, you know? So tonight, what I wanted to do was tell you guys what I think is my personal weakest subject in physics. Now, when I'm talking about my weakest subject in physics, I'm going to be referring to my weakest subject out of the 4 fundamental core physics courses you take as a graduate student in physics. So those 4 courses are classical mechanics, electromagnetism, quantum mechanics, and statistical mechanics/thermodynamics. Out of those 4 subjects, I think my weakest one out of all of them by far is statistical mechanics/thermodynamics. And I don't think it's really that close. I really think that is the subject that gives me the hardest time whenever I review and look back on it. And I think there's actually a couple of reasons as to why that is. One reason that I think statistical mechanics is my worst subject in physics is when I was an undergraduate at UC Merced, I only took one course in math that had anything to do with statistics, and it was a 1-semester course in probability and stats. And it really was the only other course besides the thermal physics/statistical mechanics course I took in the physics department that really made me apply probabilistic and statistical, thinking. If we look at the other core courses in physics, like quantum mechanics or electromagnetism or classical mechanics, if we think about the kinds of mathematics that are used primarily in those subjects, we're talking about multivariable calculus, differential equations, and linear algebra. And it's sort of in a way that all of those topics in math, all those techniques you learn in math, keep showing up in those particular subjects. And on top of that, I also did a minor in applied mathematics at UC Merced, where I actually had the opportunity to take advanced courses in differential equations and linear algebra. So I was continuously getting exposure to those subjects, and I was continuously solving problems in those subjects. And it just made me, I think, overall better because I just had more practice with those kinds of topics and how to apply the kinds of reasoning when you are dealing with those kinds of problems. I think, though, another factor that cannot be understated is pure interest in the subject itself. Out of those 4 core physics subjects, I would definitely rank statistical mechanics towards the bottom of my preferred list. So it'd probably be 3 or 4, with it possibly swapping with classical mechanics depending on how you look at it. Another aspect that I think plays into it is that statistical mechanics is one of those subjects that doesn't really have a defining overarching equation. And you could argue, I suppose, for like maybe a partition function equation or maybe the equation for entropy. But when you think about the other 3 core subjects, when you think of like classical mechanics, you could think of the Newtonian formalism, you could think of the Hamiltonian formalism, the Lagrangian formalism. If you're thinking about electromagnetism, there is Maxwell's equations. And if you're thinking about quantum mechanics, there's the Schrödinger equation. So it's like all these other subjects have sort of a go-to definable equation that sort of tells you what the field or what the subject is really about and what's the physics behind the equation. But statistical mechanics really doesn't have one particular defining overarching equation that I think makes it kind of hard to remember certain formulas and certain just equations that are used a lot in that subject, at least for me. One thing that I will say, though, is that when I was in high school, I was really interested in the subject of thermodynamics, which is developed in conjunction with statistical mechanics and are often taught together. And the thing about thermodynamics that was interesting to me was the concept of entropy and Gibbs free energy and enthalpy. And I learned all that stuff in my AP chemistry course, and I was really looking forward to learn about that stuff in college. But at some point, I think I just lost interest in those things and, replaced that interest with the interest in like quantum mechanics and electromagnetism, to be honest. So I think just losing the desire to learn more about those concepts also played a role in sort of me just not really finding the subject to be that interesting. Now, before you statistical mechanics fans out there come at me with your pitchforks and torches, let me just be upfront and say that obviously it is an important subject in physics and is an important bridge in connecting both the macroscopic and microscopic realm of physics. And I really do want to improve my knowledge in that area. So that is it for me, guys. I hope you guys enjoyed this video. What I want you guys to do is leave a comment below letting me know what you think is your subject in physics that you need to improve the most. And I'm curious to see where you would rank statistical mechanics relative to the other core physics subjects that I mentioned earlier. So that's it for the video. Like, comment, and subscribe, and I will see you guys later.